Let's pull it up. Full service robotic automation for $0 CapEx. That's what we like to hear. We love when CapEx is free. Welcome to the stream. How you doing today?
Welcome to the Anti-CapEx Club. Good to meet you guys. Thanks so much for having me on.
It's a great club.
Yeah, fantastic. Can you introduce yourself? Give us a breakdown of the company, where you're at, and what you're building.
Sounds good. Yeah, my name is Saman. I'm the CEO of Formic. We're building the robot army that is helping American manufacturers automate. You can see some of them on the screen behind me. These are our robot babies, as we affectionately call them. We have hundreds of them across more than 100 factories now in the US that are using our robots to produce all kinds of products. We're making everything from metal parts for aircraft and automotive, plastic parts for lawnmowers and golf carts, as well as things like food and beverage. We make all the nachos for Chipotle and dog food and cat food and laundry detergent. You name it, our robots are helping to make it.
You make Chipotle nachos robotically?
Let's go.
We are indeed. Yeah, the last guy I heard, Eric, was on. You guys were talking about bring manufacturing back. Like, it's real, it's happening. We're really excited to be part of it.
Yeah, what do you have to say to the naysayers that say we'll never make it in America? The haters.
The haters.
Look, I lived in China for 25 years, and I saw the industrialization of that country. Yeah. And it's not a 2-year process, right? Like, industrializing is a 20-year journey at the minimum, and probably much more. And we do have 250,000 factories in America that are making all kinds of products, so they exist. The problem is we don't have the labor force to support them, right? Yeah. It's not just about cost of labor. There are millions of unfilled jobs in factories today. The typical utilization rate of a factory in America is less than 2,000 hours a year. The comparable number in China is 7,500 hours a year, right? Like, there's 8,700 possible production hours in a given year. The vast majority of American factories are sitting around collecting dust 75% of the time. And it's not because there isn't demand for their products. It isn't because there isn't raw materials available, right? Like, it basically just boils down to the fact that there aren't people who want to work in these factories and do these back-breaking jobs day in, day out. And so until we automate a bunch of them, we're going to have a really hard time reindustrializing. So, I'm optimistic, Jordy. I think there is a lot of opportunity to reindustrialize and bring more manufacturing back, but it's not going to be in a year or two, right? Like, we're helping make that happen faster, but it's going to take some time.
Like a really dumb criticism that I don't agree with of this company, and it might be completely wrong, would be like, hey, this is just financial innovation. You're swapping CapEx to OpEx. That allows you to grow really fast. I think that could be good for reindustrialization, but how much of that is key to the business? And then what else are you doing? I imagine that you're not mining the metal to make the robots. You might even be purchasing the robots from other people and then designing software suites and integrating. But Palantir goes to, it's just a consulting shop or whatever. What is the criticism of your company of where you're starting, and then why is that the right path to start and then grow out from?
Yeah, I think it's a really good question. I think it starts from the basic premise that most roboticists are working on the wrong problem, right? Sure. I was a VC for 10 years. I was investing in robotics companies. I funded 50 different robotics companies and saw all the different ways in which they had challenges. And what I realized is look, any roboticist will tell you, getting a robot to do a job is 10% of the work. 90% of the work is how do you do error handling and how do you solve all of the shit that happens after you deploy that robot. Yeah. And I think that's the part that's generally underappreciated, which is we'll see a robot doing a backflip in a cool YouTube video. Yeah. But once you try to get that robot to do that reliably for 99.8% uptime, you start to encounter all kinds of issues, right? Joint failures, maintenance challenges, programming issues. Your in-feed, your product just has a lot more variation than you expected. Yep. And I think it's generally underappreciated. And so the reason that factories in America don't automate today is not because you can't get a robot to do this job. The problem is all the surrounding infrastructure doesn't exist. And so if you're the factory that focuses on making chocolate chip cookies, and you're really good at the best chocolate chip cookie recipe and baking, you're not also super good at deploying robots and managing them. And so what happens is they're just kind of overwhelmed. They don't know what to get. They don't know how to get it. They don't know how to manage it. They don't know how to maintain it. And so what we realize is you have to build all the surrounding infrastructure. Robotics has this last mile problem where if you can make it easy to scope, deploy, manage, and maintain the robot, then you can drive mass adoption. So we built a bunch of software that does that.
Yep.
We use computer vision and LiDAR scans to do kind of full site evaluation in an automated way. This used to take months to walk through the facility and measure every single thing to figure out what you can automate and what kind of robot you need. We do that in minutes. Then you need to figure out what robot to build and deploy. So you need to basically simulate different robot arms doing that job with different grippers, different conveyors, different safety scanners, different fencing. Like you need all of this stuff to make a robot useful. Then you need to actually program the robot to do the job. And so we basically built AI that automates the process of programming the robot. And then lastly, once that robot's deployed, you have kind of all the ongoing management of that robot, right? So how do you do teleoperation? How do you do error handling? How do you do preventative maintenance? How do you gracefully recover from all the different types of errors that you're going to encounter? There's a ton of infrastructure that needs to be built. And so like 90% of roboticists that I meet are working on how do I make the robot a little bit smarter? And nobody is working on this giant problem, which is the reason that robots aren't deployed, right? I can tell you from the hundreds of robots that we've deployed today, less than 5% of my deployment cost is programming the robot to do the thing. That's like it's completely delusional how many people are spending their time trying to make the robot a little bit easier to program. Like that's inconsequential to me. Like I need to focus on solving the other 95% of the cost of deploying robots. So I don't know if that answers your question.
Can you talk about landing on CPG and food and beverage broadly? You said you invested in 50 plus different robotics companies. I'm assuming you saw a bunch of success and failure, and I'm assuming that was super intentional to land here. And then I want to ask potentially other categories that you're excited about.
Yeah, I'll be honest, it wasn't that intentional. We started out going really broad. We were doing things in metal fabrication. We were doing things in plastic injection molding. We were doing things in CPG and a bunch of other industries. Ultimately, we narrowed back into CPG for a couple of reasons. Number one, it's the industry where there's the most amount of utilization, right? So the typical CPG factory actually runs 20 to 24 hours a day. In things like metal fabrication, like parts factories that make metal parts for aerospace and automotive, they typically run 8 hours a day of production, but actually only like 6 hours a day of actual parts being made. There's like 2 hours a day where people are setting up and tearing down. So high utilization means automation has a much bigger short-term impact. Number two, it's the industry where there's actually a lot more of it happening domestically. In metal and plastic manufacturing and other stuff, like a lot of it is still being imported today from China, from Mexico, from Canada, from other places. But because CPG products are generally low value and low margin, it's not worth it to ship them across the ocean. So a lot of that is actually happening domestically. So there are a lot of factories that can use automation. And third, those are the jobs that are the most backbreaking, painful jobs, right? Like you can afford to pay a machinist $50 an hour or $60 an hour because that's like a high value, high margin product. You can't afford to pay somebody who's packing boxes more than $15 an hour. And
they're still picking up super heavy, cases of drinks and things like that.
Exactly. Yeah, it's backbreaking.
Can you take me through kind of a market map or like the topography of robotics? Because I've watched how it's made. I've seen, a little scooper. I don't even know if I'd call it a robot. It's more just like a machine. Yeah. Then there's, 2-axis gantries. I'm seeing a lot of robotic arms, a lot of 6-axis stuff. And then you get into the humanoid world. Where's the biggest opportunity in terms of, or where's the most need to deploy, and like what type of robot is the most important to just roll out in America right now?
Yeah, I think like articulated 6-axis robot arms are still the vast majority of use cases, right? I think if you look at what humans are doing in these factories, like they're typically using their arms, not other parts of their body. So I think it's just an indicator of like that's the most common task, whether you're talking about assembly, whether you're talking about quality control, you need vision, obviously, whether you're talking about packaging, whether you're talking about even kind of primary food handling and sorting. In the metal fabrication world, you need a lot of machine tending, which is picking up a blank part and putting it into a CNC machine. We have a bunch of robots that are doing that. All of those are just kind of articulated arms that can do it. So I think there are use cases for the humanoid form factor to kind of do new types of tasks. We also have some gantry robots that we've deployed that do certain types of applications where it's like very high payload work. But to be honest, like the form factor is kind of irrelevant because in all of these types of robots that you're talking about, you have a couple of motors and some motion control, right? Like it's actually if you can abstract away the software enough, like all of those things are essentially different variations on the same problem.
Mm-hmm. I want to talk about the CapEx thing. What's the damage for a company if they're not working with you to buy a bunch of 6-axis robot arms these days? Can you give me like an order of magnitude for how much these robots even cost? I've seen a couple of them
Yeah,
in
or
the
maybe
field,
even some
but
of the
I have no
history.
idea.
Some of the history. I mean, we've seen so many companies try to automate. Bring
Yeah.
in robotics, right? Like Nike has
Yep.
a history of trying to do this in Latin America and
Ran
just
into a bunch of
failing
trouble. Yeah.
miserably despite having seemingly competent partners. So, yeah, I'd love some additional context there.
Yeah.
Yeah. So I'll start with the second question first, and then I'll move to the first question. So uh, the vast majority of robots in America today are deployed in very, very big companies. So General Motors, Procter and Gamble
Mm-hmm.
are two examples of like the biggest buyers of robots in America. They
Really?
buy like a couple hundred robots a year.
Wow.
And they have very large in-house engineering teams who can use those robots to do different kinds of tasks. The problem is 99% of factories in America are small, medium-sized businesses.
Mm-hmm.
And the logic follows like if you take a single General Motors plant that makes cars, there's 4,000 small factories that make the components that go to General Motors that get assembled into a car, right? So there's one guy who makes the windshield and one guy who makes the screws and another guy who makes the tires, right? Like every single one of those smaller factories is not automated at all today. Like 95% of them don't have any robots. So the cost is a part of the question, right? Which is it costs between a couple $100,000 to a couple $1 million to build a fully automated robot work cell. The interesting thing though is if you break down that cost, about 30% of that cost is the hardware itself, right? Like the robot arm and the conveyors and that kind of stuff. 70% of the cost is all the custom engineering that you typically have to pay for integrators and consultants and this and that to come in and try to kind of customize it to your process. And if you're a small factory, like you don't have the capacity to kind of get rid of that 70% custom engineering cost because you don't really know anything about robotics. And so the reason that we built all of this kind of infrastructure tooling around it is that we're cutting out that 70%. It costs us significantly less to go and buy and build and deploy those robots than it would be for them to try to do it on their own.
Mm-hmm. Can you walk me through who the best robot builders are in the world right now? What does the supply chain look like in terms of constructing, building, R&Ding new robots? Who are the major players globally? Who are the up and comers? I don't even know if I could name a single robot maker, but I'm interested to hear kind of like what the landscape looks like, who the major players are.
Yeah, so the biggest robot companies in the world are all not American, right? So Fanuc is Japanese. They're one of the biggest ones. KUKA used to be a German company.
KUKA.
It got acquired by a Chinese company. ABB, Yaskawa, Mitsubishi. There's a bunch of these kind of very, very large industrial companies that make robot arms. The thing to note though is that like buying a robot arm is effectively kind of useless on its own. You need a full robot work cell to make that work. So you need PLCs that often come from like Siemens or Rockwell. You need sensors that come from companies like Keyence. A programmable logic controller. So it's like it's the thing that controls all the peripherals and safety equipment.
Got it.
Yeah, and then you need like conveyors, you need safety scanners that are often made by like Keyence and Cognex and a bunch of other company. You need grippers, which is the end of arm tool.
Yep.
Today, like the vast majority of people who deploy robots basically hire a consultant that goes and buys all these different components for them and then assembles it and then deploys it for them.
Yeah, I saw this at Hadrian. They have a 6-axis robot arm and they have this like invisible wall that if you put your hand through, it'll just
a light
stop.
curtain.
Yeah, light curtain. That's what it's called.
That's right.
Why has automating 3PLs proven to be such a challenge? There's been a bunch of, Amazon had their internal efforts. I think there's like 6 River Systems, which was maybe Shopify. acquired them, but it just seemingly is such a difficult task. And you would think that, grabbing items and putting labels on them and, shipping them should be, it seems straightforward, but clearly not.
Yeah, I mean, I'll note that like we don't know a ton about 3PLs because almost all of our work is in manufacturing.
Yeah.
Logistics is a much smaller industry, and like we're not in it today. I will say, right, like logistics has to deal with a lot more variability than manufacturing. Because if you're running a 3PL, like any kind of product could come into your warehouse anytime. And so you need systems that can deal with all of them. And there's just like physics based constraints on that, right? Like if you're picking up a 1 ounce bag of something versus a 50 pound box, like you just need fundamentally different physical hardware. And that's why I think a lot of this kind of humanoid stuff is very strange, because like if you're picking up a 50-pound box with one of those robots, like it's very likely to tip over pretty easily. Like you need, and if you want to move at any kind of speed, right? Because if you take a 50-pound box and you move it at 5 miles an hour, your effective load during that acceleration is like double or triple that, right? So it's like 100 pounds of load that you have to be able to handle, which is just kind of impossible. If you move to manufacturing, like you have a lot more consistency because every production line is kind of making the same part or the same product at relatively higher rate. And so the technical complexity is lower, but the operational complexity is higher.
Interesting.
I saw that,
on the note of humanoids, are you worried about depreciation with humanoids? I think this is a concern if humanoids end up, working well, but then following the same path as like EVs, because there's like there's high wear and tear on cars, right? They're just like going down a road all the time, and that's challenging. And you can imagine humanoids are walking around with these heavy loads, and then simultaneously, like all of that interaction just feels like I worry about the economics of humanoids. If you buy a robot for $50K and the next year it's worth $10K, it's like, well, you almost could have hired a human for that kind of cost. But I'm curious what your point of view is.
Yeah, I think it depends on what the task is, right? Like if you're using that humanoid to do an occasional task, right? Like pick up your laundry and put it into the basket, for example, like you don't worry so much about wear and tear because it's low frequency. If you're talking about a manufacturing use case, right? Like these robots behind me, all of them operate 24 hours a day. And so at that cycle rate, like you're doing maybe 50,000 cycles a day. At that rate, like the wear and tear you get on all of the components is very high. And like a 6-axis robot has 6 motors. A humanoid, most of these humanoids that we've seen have something like 30 to 50 motors, right? And so you're just talking about like the wear on the motor. Like we have to go out and lubricate these joints and replace motors on a pretty regular basis. I can't imagine if I had to do that for 50 motors instead of 3, right?
Yeah.
Speaking of motors, I saw that in the latest Boston Dynamics demo, they said that they switched to electric motors. Is that a meaningful shift in robotics, or is that something that's unique to their approach to building humanoids?
Yeah, so most of the robots that we use servo motors, so they're all kind of electric motors. Okay. It's pretty standard. Some of the new humanoids are using linear actuators, which is a newer technology, and I think the Tesla humanoid is doing that. It's like the exact kind of wear and tear profile on that is not clear, and a lot of them are actually building their own motors from scratch. So like the Chinese, like I think this is a place where China has a huge advantage compared to like a lot of the American startups. Like Unitree, for example, which I'm sure you guys have seen those videos. Like they have built an entire team to build actuators, and a whole team that's building their own custom LiDAR, and a whole team that's building their own kind of custom sensing across a bunch of, for most of these American companies, it's kind of inconceivable to go and try to invent your own motor and try to figure out how to build a humanoid. But in China, it's possible to be much more vertically integrated.
That's so odd, because you have to imagine back in the dawn of the automotive revolution, like Ford was certainly building motors and wheels and tires and seats and the frames and stuff. Like we did have the ability to have a vertically integrated supply chain at one point in America. and then we just decomposed it so much that it's been a struggle to get back to vertical integration. Very, very tricky.
The management consultants got hold of us.
They did. They did. Yeah, on humanoids, I don't know if you've been following what physical intelligence has been doing with some of the end-to-end models, this idea of generalization. Are you looking at any software approaches that are more, I don't know, big data or deep learning driven to handle more of those edge cases to automate the last 90% of the work that you're doing? And what are you following on the AI side of things these days?
Yeah. So I think these vision language action models, like what physical intelligence is doing, are very promising. We're running trials on some of those vision language action models for some of our use cases. The problem today is that they're just generally too slow for us to be able to use them in a kind of commercial setting. But I think that'll get better in the next few years. So there are, in the common trajectory for us is we'll start out in a factory with 1 or 2 robots, and then the factory will come to us and say, hey, can you help me automate all these other tasks on my production line? And today some of those are solved and some of them are not. And so as we go, as these vision language action models get better and other kinds of techniques around deep learning get better, we'll start to go and address more and more of those tasks. Yeah,
Jordan,
I mean,
this is great.
Yeah, continue.
I was just gonna say, I think that the thing to note here is we're just at a very different place compared to more established automation economies. Right? In China right now, last year there were about 400,000 robots deployed. In the entire U.S., we had about 30,000 robots deployed, so less than a tenth of the amount of robots deployed. In a place where the labor cost is so much higher that you could theoretically justify a much higher use case of robots. And I think a big part of the reason is China just has so many more engineers that they can put towards the problem of design and deployment. Plus, they subsidize a lot of the kind of robotics industry to be able to go and make it easy for people to deploy.
Yeah,
I think in the U.S. we have this challenge where there's a lot more small and medium-sized businesses, and we don't have the historical infrastructure or the engineering capability for all these plants to figure out how to automate on their own. And so building this set of tooling and helping them figure out what are the latest things that are happening in kind of AI and machine learning and computer vision that we can apply to the different use cases in your facility is, I think, the only way that we can move faster than China in the long run. Is
there anything that you want to see from the U.S. government to speed up the deployment of robotics in America?
Trillion dollar contract.
I mean, you could imagine subsidies or incentives or a strategic reserve of robots. But you could also just look at deregulation. But I don't know what your take is.
Yeah, I mean, so I'm excited to go to the Hill and Valley Forum next week and talk about that a little bit. But frankly, I don't think there's much that's necessary, right? I think the incentive is there, right? There's plenty of financial incentive for these small and medium-sized factories to do it. To be honest, the biggest barrier to adoption of robotics in America is it's a cultural change, right? These factory owners, a lot of these are 3rd generation businesses, right? They've been passed down, or they're kind of private equity owned. And in both cases, you end up with these businesses that are very risk averse. They're afraid to adopt new technology. They don't have the internal capabilities to do it. I think from the government side, things that are being done around educating that group of manufacturers and helping them to deploy automation will have a very big impact. Similar to what China does, actually in the US, we've had subsidies for small, medium-sized factories for the last 10 years to buy automation equipment, right? There's accelerated depreciation. A lot of states have matching grants where if you buy a $500,000 piece of machinery, the state will grant up to 50% of that cost. And so we've had plenty of these incentives in place, but adoption is super low. When we talk to the states, most of them say we can't give out these grants. Nobody's using it because people don't know what to buy. They don't know how to buy it. And once they buy it, they can't handle the responsibility of this new piece of equipment. And so there's tons of grant dollars just sitting around, not getting deployed because there's this barrier at the last mile.
Makes sense. Very informative. Thank you. Yeah, we'll see you at Hill and Valley.
Yeah, we'll see you next week.
Awesome. Look forward to it. Appreciate you guys having me on.
Have a great rest of your day.
Cheers.
Goodbye.